Hello everyone. In this video, I'm going to derive the equation that provide the volume of a cone. For this working, I use integration to derive the volume of the cone. Let's say the bottom circle radius is r and the height of the cone is h. Then the equation will be v equal 1 over 3 times 5 times r square times height of the cone. For the to derive the equation, I use integration. Let me clear this drawing and let's see how the workings will be. This is two axis. One is for y axis, another one is for x axis. On this coordinate system, I am going to place my cone. And let this angle to be theta. And we know the height of the cone is h. Let's don't put it here. Let's put that h here. And here 0 0 and here 0 r, because the bottom circle the radius is r. For the integration workings, let me select a very small plate in the middle of this cone at x distance from the origin. The thickness of this plate, let's consider it as delta x. It's a very small distance. So if we say the volume is v, then we can say that it is equal to the integration 0 to h, and we integrate this the volume of this plate across this h distance. That's why I put this 0 as lower limit and h as upper limit, because we integrate this the volume of this plate from 0 to h. That's why the expression for the volume of this disk, that means the plate, actually if we look at from the bottom, we can see that this plate is a circle. It has a radius. We don't know the radius. Let's put the radius as r. Now let's find out what is this r. If I draw the upper triangle of this cone, upper triangle means this triangle, and this angle is theta. Angle is theta, and this distance is r, and this distance is h. Then I can write the equation for the tan theta. Tan theta is equal to R over H. Similarly, I can write the equation for this distance. This distance is R actually, because this R represent this distance. Angle is same theta, and this distance is belongs to represent this distance. That is, the total distance is h, and if we subtract this x length, this distance will be h minus x. H minus x. Then tan theta is equal to r over h minus x. Then r equal x h minus x times tan theta. Then if I draw this plate over here, this actually this distance is ds. This is actually a small cylinder, very thin cylinder. The radius is r, and this height of this cylinder is h. What is this cylinder? This is the mass we shifted for the integration, and this plate I converted it into this cylinder. If I write the equation for the volume of the cylinder, that is V equal cross section is 5 r square times the height of the cylinder is Vx. Then if I substitute this r value here, 5 h minus x tan theta square dx, I get 5 tan marga theta tan square theta h minus x square dx. Now let's put this expression in this integration. Let's simplify this. 5 tan theta is equal to this ROH means, if I simplify this, I can take the constant out from this integration, and now let's do the simplification of this integration. Is q over 3. limit is h, no limit is 0. Then if I substitute these limits, you can see each of the term contains x. Then if I substitute the 0 to that this expression, it will be 0. Then I just need to substitute the h for this expression. Here I have missed this h square. Then answer is 103 5 r square h. This is the final answer.